Okay. I had a few things for us to talk about before we get into algebra mode. Here. Let's see. So number one, in Canvas, you should be able to see your WebAssign assignments now. So they should show up over here on the to-do list. You can just click on them and it'll log you into WebAssign. You can go straight to the assignment. And also, if you like using the calendar in Canvas, they should show up there as well. It's a little green assignments there, and then you can click on them and it'll take you straight to that assignment from there as well if you want to. One thing that changes a little bit is, let me get back to, is there's a bunch of stuff if you go to your grades. You'll have a spot for a grade for every assignment. Remember just the total percentage, what counts in here, so you can just really look at the bottom. It is nice, you can see if you're missing any points on anything there. But so we got the WebAssign assignments, and then we'll have tests, and then potentially optional final exam down there. That there. It should be able to, maybe that'll help keep track of things. I know you got several classes, it's hard to keep track of what's due in which class sometimes. Okay, and then also just something I wanted to point out in WebAssign, something that I had not thought to tell you before, I don't think, is that if you miss a due date on an assignment and you need to ask for an extension, if you're on the little home screen in WebAssign, you can click on the past assignments button down here, and it'll eventually load up, maybe. And you can click request extension there. That's how you ask for an extension in here. So what that does, just so you know how it's working, what that does, when you click request extension, it sends me a message and says you've asked for an extension, and then I go to WebAssign and can give it to you in there. So it's just as good as emailing me. It sends me an email automatically. So that lets me know. Okay, and then also, last thing on my list here. Also, we'll just put this off to the side right here. Starting to try to forecast when our first test will be. So it's looking like probably maybe on February 10th. So we'll be able to nail it down more concretely when we get just a little bit closer. Let's see, that is Thursday, I think. Yeah, Thursday, February 10th. But what it's looking like right now, so I don't think it will be any earlier than that. That's what we're thinking. Questions about any of that stuff? Yep. No, just you got the whole period, take the test, and that's it. But it'll be after. Yep. Be at our regular time. Have a old-fashioned paper test. Think anything else? Anybody had problems on WebAssign giving them trouble? Need to ask about? So also, when you're working on a web assignment, each question has a little link on there that says "Ask your teacher." It's fine to use that. That sends me an email, and I can see what you ask, and then I can see the problem you're working on. So that helps me. I don't have to get you to screenshot it or anything like that. Feel free to make use of that. If it's a busy time, like an hour before the due date on something, it might take me a minute to get back to you. I get to answer you as soon as I can. All right. So we got one due tonight, right? We've got the, which one was it? The algebraic expressions where you're adding and subtracting and multiplying algebraic expressions. It's not very long, but it is due tonight. So try to refresh our memory a little bit and pick back up where we left off. We are working with complex numbers. We added and subtracted these things, and then we said we could treat I just like a variable in that case, and then really you're just combining like terms. You do have to be more careful with the signs when you're subtracting. And then we started looking at multiplying a little bit. We said the thing we have to pay attention to when we multiply, we still can treat I like, use all the same rules we do with variables when we multiply with x's or something in there. But when we go to simplify, you're going to make use of the fact that I squared is -1. So we don't want to leave I squareds in our answer. The first one there, we did distributive property, and then we can use the other stuff we know about multiplying, like we did FOIL. There, when we did FOIL, we got an I squared, so we changed that to -1. And we're putting our answer in A plus BI form. So let's do one more to warm up. Do another multiplication here. We'll do another FOIL. Let's multiply these two complex numbers. 8 minus I, 3 plus 2I. So we can use the FOIL method. And so we do 8 times 3, that's 24. Do 8 times 2I, that's 16I. Doing the outer terms there. If we do the inner terms, -I times 3 is -3I. Then when we do the last terms, we have -I times 2I. So we get -2I squared. And then hopefully that makes us feel uncomfortable that we have an I squared there. We gotta remember I squared is -1. So two things to do. We can combine our like terms in the middle. So 16 minus 3 is 13I. And then here we've got 24. Here, -2 times -1 turns into +2. So 24 plus 2 gives us 26. And if we put it in the normal order, we have 26 plus 13I. And you don't have to do all that in one line. If you want to do it in 2 lines, that's fine. Or 3. You think you got the idea on those? A little bit? Okay. Alright, so that's multiplying. Okay. The next type of topic we want to talk about is, get me in. We want to talk about dividing these complex numbers. So in the situation where we're dividing a complex number by something, or we're dividing by a complex number, so let me get one up here so we can talk about what's going on. Okay. We call it dividing. That's technically what we're doing. We're saying 6 divided by the complex number 6 plus I. And the fraction bar just means division. But when we're dealing with complex numbers, the way we carry it out is a little bit different. So we call it dividing, but really what we're going to do is more like rationalizing. Like if we have a radical in the denominator, we're trying to get rid of it. That's really what our technique's more similar to. And that kind of makes sense, not because I, our imaginary unit, do you remember what our definition? I really is, I equals what? I squared is -1. So I is square root of -1. So really, we've got a radical anytime we have an I. So we really do kind of have a radical in the denominator here. So let's hit pause on that for just a second. Let me scroll over sideways. Let's talk about rationalizing when we don't have an I. So if we've got something like this. So we talked about some where we had the case where we just had a radical in the bottom, just had a radical in the denominator. So if we just had square root of 3, so 2 over square root of 3, then we could multiply by square root of 3 over square root of 3, and that would get us where we needed to be. But in the case where we have 2 terms in the denominator, we have to be just a little more creative. And the thing we would multiply by, you may remember this. Anybody remember what we multiply by? It's related to the denominators. We do need square root of 3. If we didn't have the 1 plus, it would just be square root of 3 over square root of 3. The 1 plus throws us a little bit of a curve. So the change we have to make, instead of just multiplying by the denominator, we got to multiply by 1 minus square root of 3 over 1 minus square root of 3. So we change the sign in between the 2 terms. And the reason why we do that is so when we multiply the bottom out, so let's do FOIL with the bottom 2 terms. So 1 times 1 is 1. Do the outer terms, 1 times negative square root of 3 is negative square root of 3. We do the inner terms, square root of 3 times 1 is just positive square root of 3. And then on the last terms, we have positive square root of 3 times negative square root of 3. We're never going to get a negative, because it's a positive and a negative. And then square root of 3 times square root of 3, you can either think about that as square root of 3 squared, so the squares cancel and we get 3. Or you can think about it as the square root of 9. The square root of 9 is 3. And then the nice thing happens. Okay? What happens with our middle 2 terms? They cancel out, yeah. So negative square root of 3, positive square root of 3, they cancel out. And here we would end up with -2 in the bottom. So the reason why we change the sign in between is so we get this cancellation in the middle, because we don't want to have radicals in our answer. So that gets rid of the radicals. So we're going to do similar idea here. We've got 6 over 6 plus I. So we're going to change the sign between the number and the I here. So we're going to multiply by 6 minus I over 6 minus I. This thing has a fancy name. It's a complex number, so we say it's complex. And then when you change the sign between the 2 terms, that's called the conjugate. So we're going to multiply by the complex conjugate over itself. It means we change the sign in the middle. Then again with fractions, we multiply the tops and we multiply the bottoms. The tops on these, when you're doing the numerators, you don't necessarily have to multiply it out unless you have a good reason to. So I'm just going to keep it written as 6 times 6 minus I for now. If I see a good reason down the road to multiply that out, I will. Otherwise, I'm going to leave it. Then on the bottom, we do FOIL. 6 times 6 is 36. 6 times negative I is negative 6I. I times 6, 6I. Those are going to cancel. And then the last terms, we have I times negative I. So that's negative I squared. So middle terms go away. That gets rid of those two i's. What else happens? I squared is negative 1. So this I squared turns into negative 1. In this case, we've got a negative, negative 1. So that's really plus 1 because of the negative and the negative plus 1. So what do we end up with on the bottom there? We just end up with 36 plus 1, get 37 on the bottom. And on the top, we've got 6 times 6 minus I. So sometimes, really the reason why I suggest not to multiply it out right to start with, sometimes, like if this had been 36 on the bottom, then we can cancel. We can reduce. Here, 37 is a prime number. We don't have anything we can cancel. And this thing's going to tell us to put our answer in A plus BI form. So I got to have something plus something I. So that's our good reason in this case to multiply the top out, because we got to put it in A plus BI form. And unfortunately, we didn't get anything to cancel to help us. So on this particular one, yeah, I would go ahead and distribute the 6 on the top. So that's 36 minus 6I over 37. And then to put it in that standard form, we want the A plus BI form. One other thing we can think about is that if you have something that over a denominator, now we've got multiple terms over a denominator, you can split it up. It means the same thing if you take each term in the top and put it over the denominator. And so we could write this 36 over 37 minus 6 over 37. Now this is just putting our answer in A plus BI form. So if it makes us put our answer in A plus BI form, that would be our answer. All I'm doing is splitting that up. That's like the reverse of when you get a common denominator, then you put it together. That's just going the other way. Questions? We're going to do more. All right, so that's what I would call doing it the long way. And because we actually did the FOIL method on the bottom. And then we had to do all that simplification after we did the FOIL method. Okay, but it turns out there's a shortcut to know what you're going to get anytime you're multiplying complex conjugates. And that can help us. You can do FOIL method every time, and that's fine. It'll work, no problem. If you want to put in the effort to learn a little shortcut, then it'll save you a little time, and you can. So if we have complex conjugates that we're multiplying, so one will look like a plus bi, and the other one will look like a minus bi, the answer we get is always going to be the first number squared plus second number squared. And you can, if you take the little pattern and you check it, we get plus ABI minus ABI, those cancel. And then we get minus B squared, B squared I squared. And the I squared turns into -1, so it changes to minus to plus. So here. Pattern. And we can see it worked out that way. Because on this one, our A was 6, our B was 1. So 6 squared is 36. 1 squared is 1, and it was turned out positive. 36 plus 1 is 37. You can do shortcut, or you can use FOIL. Actually go through the whole process. Either way works. Let's do another one. If you get comfortable with multiplying the complex numbers, then the only other part that's tricky, the only new thing with division is remembering what you're supposed to multiply by. Remember to multiply by the conjugate over itself. On this one, we happen to have a complex number in the top and in the bottom. That doesn't change anything. When we're deciding what to multiply by, we just want the conjugate of the denominator, the conjugate of the bottom. That means we're going to multiply by 1 plus 5i, or 1 plus 5i. So on the top again, I'm not going to worry about multiplying that out just yet. I'm going to call it 52i times 1 plus 5i. Might get lucky and something might cancel. On the bottom, okay, you could go straight to the shortcut, right? So it would be 1 squared, so that's 1 plus 5 squared, that's 25. So I know we're going to get 26 on the bottom using the shortcut. But I work it out doing FOIL, because I know a lot of people don't like to worry about the shortcut. So 1 times 1 is 1. 1 times 5i is 5i. Negative 5i times 1 is negative 5i. Those are going to cancel. And then negative 5i times 5i, get negative 25i squared. But the I squared is -1. So that turns this into plus 25 over here. 5i, negative 5i, those cancel. On the bottom, we get what we figured out we would get with the shortcut. 1 plus 25, so that's 26. On this one, our life does get a little bit easier as far as when we have to go to multiply out, because 26 goes into 52 and it goes into 26. If you don't see that right away, maybe you could say 2 goes into the top and bottom. Get 26 over 13. Maybe you could say 13 goes into both of those. So 26 will go into this twice and into this once. So that leaves us on the top. We've got 2i times 1 plus 5i. These problems will tell us to put our answer in a plus bi form, so I do want to distribute. 2i times 1 is 2i. 2i times 5i, 10i squared. Got another I squared in this problem. I squared is negative 1. So that plus 10 turns into minus 10. And then if we're wanting it in a plus bi form, we just got to switch the order. That would be negative 10 plus 2i. A plus bi form. Kind of had double simplifying we had to do on that one because I got that extra I squared term in there. I need to walk back through any steps or parts you're not sure on. Okay. Hard to believe, so be brave if if you're not sure on part, let me know. All right, so those they don't really get much worse than that. The only thing that we would run into that would make it any more complicated is if maybe we had two terms on the top, then you just end up doing FOIL method on the top. It's not. It just makes it longer. It doesn't make it harder. At the bottom, the denominator is the one we focus on and know what to multiply by. We take the conjugate and then go from there. No questions on those? Okay, so one other operation we want to be able to do with complex numbers, and as fun as algebra class can get, this last one's kind of fun from algebra perspective, so more fun for some people than others. Because this is something we can't do with real numbers, with our regular numbers we use. We're going to simplify different powers of I. If you just have a real number, if you've got 7 to the 50th power, the only way you could even think about trying to simplify that is you have to actually find out what the answer is, right? You have to do 7 times itself 50 times and get an answer. But something interesting happens, maybe interesting to some people, happens when you start raising I to different powers. So let's look. If we've got I to the 0th power, you remember what anything to the 0th power is? 1. Arguably, depending on, some people say 0 to the 0th power is undefined, but anything else to the 0th power is 1. Okay. Then I to the 1st power, anything to the 1st power is just what? Yeah, you can do that. Anything in the 1st power is itself. So that's just I squared, we've talked about quite a bit. I squared is negative 1. Negative 1. Okay. I to the third. Okay, so let's think about how to figure that out. We've got I to the third. That's the same thing as I squared times I to the first. Because if you multiply, you would add the exponent. I squared, we know, is negative 1. I to the first is just I, so we would get negative I. Now, what about if we wanted to know I to the fourth? I to the fourth we could break down as I squared times I squared. 2 plus 2 is 4. So that would be negative 1 times negative 1. Negative 1 times negative 1 will give us what? 1. Anybody got a guess on I to the fifth? I to the fifth, that's I to the fourth times I. We said I to the fourth is 1, so 1 times I. I got a guess on I to the sixth? Negative 1. And one way you could break that down is I squared times I squared times I squared. Because we know that one, that's negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1. 1 times negative 1 is 1. How about a guess on I to the seventh? It is negative I. Okay. So no matter what integer, anyway, exponent, we raise I to, we've only got one of 4 possibilities for the answer. Okay. We're either going to get 1, I, negative 1, or negative I. Because if we keep going, we get bigger and bigger exponents. We call that, we have a cycle. All right, we'll go back through the cycle. The pattern just repeats over again. So what we want to be able to do, we want to take some power of I and figure out which one of these 4 simplified answers it breaks down to. So a few different ways you can go about it. You really don't have to keep too much in your memory to be able to do these. Some people like to remember that I to the fourth is 1. 1's an easy number to work with when you're breaking things into pieces. Or we've already got one that we've got to know, right? We've got to know I squared is negative 1. So you can break down a bigger power of I based on either one of those and get to the answer. There's other ways you can do it too. I'm probably going to do the ones I do for all of us with I squared, just because that's something we already have to remember. So let's look at one and get an idea of what I'm talking about. There's I to the 56th power. So if I'm thinking about that I know I squared is negative 1, I can use that. Because here, 56 is an even number. You can divide 56 by 2. So we can write, not T, I. You can write this as I squared. And then if we divide 56 by 2, that's 28. So that's I squared to the 28th power. And I just divided 56 by 2. Leaves me with 28. So our rule, if we're going the other way, is if we have an exponent raised to a power, we would multiply, so 28 times 2, we get this back to 56. But I know what I squared is. I squared is -1. That's -1 to the 28th power. And that's something we can figure out without a calculator. Because how does that work out? It might not be something you thought about, but so -1 times -1 will give us +1. And that happens when we have two of them. If we did -1 times -1 times -1, the first two would give us a positive. Positive times a negative would give us a negative, so it would be negative. So the way this works out, we have -1 to an odd power. That's -1. If we have -1 to an even power, like 2, that's +1. So here we've got -1 to the 28th, which is even, so our answer is 1. Okay. Do another one. Let's simplify I to the 46th power. So again, I see that's even. Okay, I'm going to divide it by 2. So I'm going to figure out how many I squareds I would have to get I to the 46. 46 is 23 times 2. If you do 46 divided by 2, you get 23. I know I squared is -1. And -1 to an odd power is -1. Not bad. Okay. So far, the two we've done, we started off with an even power. So let's do one where we start off with an odd power. That's the only other little thing we're missing. Kind of what technique do we use for that? So let's see. Do I to the 79th. So if I start off with an odd power, it's not 2's not going to go into it evenly. So I've got one little step I can take before. I'm just going to break off one of the i's and put it by itself. So I'm going to say this is the same thing as I to the 78th times I, the first. That would be I to the 79th. Now 78's even. Okay. That one, a little harder to divide in your head. It might be real hard, but you can use calculator. 78 divided by 2, 39. But just don't forget the extra I that we have out to the side. And then I squared is -1 to the 39th power. -1 to an odd exponent is -1. That's times I. So our answer is 55. Not bad. When you get the technique down, it's really not that much harder to do like a really big exponent. So like, sorry, let's do I to the 1501. It's not really that much harder. Maybe for dividing the exponent by 2, you might need a calculator, but that's not. 7's odd, so I know I got to break one off. So I'm going to say that's I to the 1500th times I. $1,500 is even now, so I can break that down by dividing it by 2. Powers of I squared. So that's 750 times 2. Okay. I know I squared is -1, so that's -1 to the 750 times I. $750 is even. So I know -1 to an even power is +1 times I. Yeah. And I need I to the 1,501 power is just I. Not bad. Again, this part where I'm using I squared, you could use something else. You would just divide by whatever the other exponent is. So some people prefer doing I to the 4th because then they don't have to worry about odd or even, because I to the 4th is always going to be +1. Do it that way too. You just have to break off however many i's you need to get to an exponent that's divisible by 4 if you're doing I to the 4th. Questions on those? You sure? Okay. That's the end of that section. That was 1.5, complex numbers. So time looking. Okay. We're going to get started on the next section we're covering. A little weird. I do them out of order from the textbook. So really the next section we're going to talk about is 1.4. Solve quadratic equations. In theory, you've done all of these before. Maybe a little rusty. So what we're going to do, there are several different techniques you can use to solve a quadratic equation. So we're going to talk about all the major methods for solving quadratic equations. And by quadratic equation, what I'm talking about is if we have something in this form. So this is actually our first equation in here, okay, where we have an equal sign. So here, A, B, and C, those are just real numbers, what we call our coefficients. And then the largest power of x we have involved is x to the second power, x squared. So a little different root word than you're used to seeing. We don't call these quadratic equations, even though that would probably make more sense to most people. Here, quad is 2. Okay, quadratic. That just means we have an exponent of 2. All right, so let's do one. You don't, in the past, in algebra class, you may not have been allowed to use this particular method. So you can use it in here, though. So let's look at this. This is when we have something like x squared equals 16. So the situation where this works is if we don't have an x, we just have the x squared part. And we can solve it to get the x squared part on one side by itself. Then what can we do? We're trying to cancel out the squared exponent. So what would reverse having an exponent of 2? What would be the opposite operation of that? Square root, yeah, square root. So here we can take the square root of both sides of this thing. Sometimes in intermediate algebra and stuff, you don't get to use this. So we can take the square root of that. But we've got one thing we need to remember. And I'm actually going to move my equal sign a little bit. If we're taking the square root, we're actually going to have 2 answers. Because here, square root of 16, that's asking what times what gives us 16. There's 2 answers to that. Right? Because 4 times 4 will give us 16. And what else? Yeah, we have -4 times -4. 2 negatives make a positive, right? We get 16. So we're really going to have 2 solutions here. So the way we handle that is we'll have plus and minus. Okay? So we'll have the positive answer we get for square root of 16 and the negative answer we get for square root of 16. On the left, when that simplifies, that's just x. On the right, square root of 16 is 4, so we get plus and minus 4. And so that's an abbreviated notation. What that's saying, what that means is that we get 2 solutions. One, we get x equals 4. The other, we get x equals -4. That was kind of squiggly. So anytime you can get yourself into a situation, and it works out when you don't have an x to the first power term, you just have x squared involved. You can get the x squared term by itself on one side, and you can take the square root of both sides. You just got to remember you're going to get 2 solutions, a positive and a negative. So that works. Okay. So another way it can look where you can use this, another situation here. I'm going to use 16 again. Like this situation. Thing we have on the left is a perfect square. So we know how to find the square root of the left side of this. That's saying x plus 2 times x plus 2. This is really almost giving us the answer. So since the thing on the left is a perfect square and we know how to take the square root, we can take the square root. So we'll have the square root of x plus 2 squared equals plus or minus the square root of 16 on the left side. What happens? Square root of x plus 2 squared. The square root and the square take care of each other. They cancel each other out. So over here we're just left with x plus 2 equals, we already figured this one out last time, we got plus and minus 4. And to solve for x, we want x by itself. Right now we have x plus 2. So what can we do to both sides? Subtract. Yeah, we can subtract. And this is a little weird when you've got a plus and minus sign involved. There's really nothing wrong with writing it like that, plus minus 4 minus 2. You just don't ever see it that way. Usually what we do is we'll put the plus minus in the middle, so we'll have like negative 2 plus minus 4. And so we get two solutions here. One we get by using the plus sign in the middle, so negative 2 plus 4, 2. That comes from using the plus sign. And then we get one by using the minus sign in the middle, so negative 2 minus 4, we get negative 6. That comes from using the minus sign. Two solutions. Could we have done that one a different way? Yep. We could have, but that way works. You could have pulled this side out and then made it equal 0 and use some other method. We'll see. That works because we had a perfect square on one side. Really, we had a perfect square on both sides. That just made the other side come out nice. You only have to have a perfect square on one side. So call that method using taking the square root of both sides. It's nice when you can use it. It just doesn't always work because, like I said, we have to have a perfect square on one side. So we know how to take the square root. X squared, that's a perfect square, so we could do it. And then we had that x plus 2 squared was a perfect square. Doesn't always work though, doesn't always. Okay, so that's out. Then we've got old reliable. We can use factoring sometimes. Factoring. So in order to solve a quadratic equation by using factoring, what we want is we want to get our quadratic equation in kind of what we could call that standard form, where we've got everything on one side and then the other side equals 0. And then we factor. The reason why factoring is even an option comes down to the fact that we have it equal to 0. So we've got a property, so let's go a little side note here. We've got two numbers, a and b, and we multiply them together, and we get 0. There's only 3 ways that can happen. So that really locks down our possibilities for the numbers a and b. What's one option? Yeah, one of them has to be 0, so that really gives us two options, right? A could be 0. 0 times anything is 0. B could be 0. Anything times 0 is 0. Or they both could be 0. 0 times 0 is 0. So three possibilities. One, our first number is 0, our second number is 0, or they're both 0. That's the only way we can have a product with real numbers and get 0. So 0 is special. If you set this other side like 5, we don't have a limited number of possibilities anymore. I can give you an infinite set of A's and B's that give you 5. And so now we're at infinite options there. The 0 is the special part. So we got to have it equal to 0 before we factor, because that's the thing that gives us these limited possibilities. So let's try it. Let's factor. Here we've got a 1 leading coefficient, so it's not too bad. We need factors of 32 that will sum up, add together, and give us -12. So that might take a second. If we need to, we can list out factors of 32. So let's see, 1 and 32, 2 and 16, 4 and 8. No, I think so. We're trying to get -12, and we've got a positive number. So the only way we can get a positive 32 is if both of our factors are positive or both of our factors are negative. So we know, since we're trying to get a negative number, they both got to be negative. So which ones work? 4 and 8. Yeah, if we do -4, -8, that'll give us -12. So we know x times x will give us the x squared we need. And then now we know the -4 and the -8 will give us the rest. That's the factoring part. Now we make use of our little side note property. All this is saying is we've got one number times another number, and our answer is 0. The only way that can happen is if this first number is 0, or this second number is 0, or both. So let's figure out when those happen. So we set each factor equal to 0 and solve for x. So on the first one, we add 4 to both sides. So the first one will be 0 when x equals 4. Then we can add 8 to both sides. The second one will be 0 when x equals 8. So the only way our quadratic equation up here can be true. And x equals 4, x equals 8. Two solutions. Oh man. Questions on that one? Hanging in there? Hang in. Let's do another one. This is just same idea, but just different numbers here. Yeah, I know. Okay. Quadratic equation. We can't factor yet though. What's the problem? We gotta get it equal to 0. We gotta get 0 on one side. Okay? It doesn't matter which side. You can put write it where it's on the left or on the right. We just gotta have 0 on one side of the equal. So here we've only got one thing to move. We've got the 12 we need to move over, so we can subtract 12 from both sides because it's a positive 12. And on the right, 12 minus 12 is 0. Now we've got what we need. So we're ready to factor. Don't lose your equal 0. Bring it along for the ride. Here we need factors of negative 12. That will give us negative 4 in the middle. So since we're trying to find factors of negative 12, one of our factors is going to be positive, one of our factors is going to be negative. We're trying to get negative 4. Let me see the ones that work. Yeah, 6 and 2, which one's negative? 6. We want the bigger one to be negative because we want a negative number in the middle. So here we can use plus 2, minus 6. Now we've got two numbers multiplied together that equal 0. Only way that happens is if the first one is 0, or if the second one is 0, or it could be both. Subtract 2 from both sides. Get one solution, it's negative 2. Add 6 to both sides. Get our second solution is positive 6. And something we don't do enough, we can check these. We can know if they're right or wrong if we've made a mistake somewhere. How do we check them? Plug it back in. Yeah, plug it back in. So if I've got 6, we'll do the one with the bigger numbers here. Okay. You could go all the way back to the original. I'm going to go to where we had it solved for 0. And so what do we end up with? Minus 4x minus 12. So that would be 6 squared minus 4 times 6 minus 12. That should equal 0, does it? 36 minus 24 minus 12. If you check that, yeah, 36 minus 36, that is 0. So that works. And you can do that part with a calculator. You don't want to waste your time writing all that down. Nothing wrong with that. If you went all the way back to the beginning, if you plug your answers in here, what should you get on this side? 12, yeah. You just gotta get whatever you have on the other side of the equal sign. I plugged in right here, but you could plug in right here if you wanted to. Okay. Questions? Let's do one more technique. This one's probably not gonna be too bad. That's what everybody falls back on. Quadratic formula. It's not a bad fallback because quadratic formula will always work. You can solve any quadratic equation using the quadratic formula. Nothing bad about it. Just sometimes it's not the best choice. Sometimes there's easier or faster ways to get to the solution, but quadratic formula does always work. And so here, if our quadratic equation is in that kind of standard form that we've been using, so we still want one side to equal 0 before we start plugging into the quadratic formula. Then, so let's see if we've got that, then we can solve for x using this formula. Anybody remember it? I know somebody remembers it. It's all right if you don't. And the opposite of b, or negative b, plus and minus square root, yeah, b squared minus 4ac all over 2a. So the a, b, and c, I don't know what some of y'all are getting taught in high school, but the a, b, and c are just those coefficients. Okay, it's the coefficient with the x squared, the coefficient with the x, and then the one that doesn't have an x, the one we call a constant term. I don't know why the last couple of years I've seen a lot of people like trying to put x's in here. And the x is over here. All of these are just numbers. Let's do one. To me, the downside of the quadratic formula is sometimes you get stuck doing a lot of simplifying. And simplifying radicals especially is not always a lot of fun. So let's see. Here's one that I would say is a good candidate for quadratic formula. 3x squared plus 7x plus 4 equals 0. I would say that's a good candidate for quadratic formula because we have a 3 leading coefficient. So I may not want to. It just depends on how comfortable you are with trying to factor. Now, not everything's going to factor with integers, so that's when we would say it doesn't factor. So not every quadratic equation will factor. So here we could use quadratic formula. That would be fine. So when we're using quadratic formula, what's our a going to be? 3, just the number, that's a. B will be 7, and C will be 4. So one other thing to look out for before you start plugging into the quadratic formula, make sure you're actually picking the right numbers, okay? Because you may have a quadratic equation given to you that's not in this order. So a is always the coefficient with x squared. B is always the coefficient with x. C is always the constant. And if you're missing any of those, like if this was just 3x squared plus 4, if you're missing a term, what's your number? 0. Yeah. So nothing, if there's nothing there, 0. Okay, so let's do this one. So b is 7. So I'm going to have the opposite of that. So negative 7 plus minus square root. I strongly recommend on the b squared part you put parentheses. I strongly recommend we put 7 in parentheses and square that, because if b turns out to be a negative number and you're typing this in your calculator, you can have sign issues there. Then minus 4 times a, which was 3, times c, which was 4, all over 2 times a, which was 3. So there are our answers. So we need to simplify. So, do as much or as little at a time as you're comfortable with. Let's see. So 7 squared is 49 minus So negative 4 times 3 is negative 12. Times 4 is negative 48. Be careful with the sign there as well. Over 2 times 3 is 6. (49 minus 48), that's nice and easy. That's 1. Square root of 1 is what? 1. Square root of 1 is 1. Negative 7 plus minus 1 over 6. Two solutions. Two solutions here. So if we use the plus sign, we've got negative 7 plus 1. That'll be negative 6. Negative 6 over 6 is negative 1. That comes from using the plus sign. If we use the minus sign, negative 7 minus 1 is negative 8. Negative 8 over 6, that reduces, what's that? Negative 4 over 3. Okay, our two solutions. All right, I can feel the brain fatigue, and just general fatigue. I know how it is. So, we'll stop there. We'll do some more quadratic equations. We'll do some more quadratic formula starting Thursday. Okay? You ready to go? If you didn't get on the sign-in sheet, make sure you get on there before you go. It's in here somewhere. Yep.
Am I allowed to use that formula?
Yeah. Okay. Yeah, that's okay.
But that only works if there's no
Right. Yeah. It's okay. Oh, sheet. Need a sheet. There you go. Right there. Need a pen. You can use my pink one if you want to. You're welcome. Yeah, that's all right. Yes, I need. Thank you. It might be on the back. Thank you.